similar grounds, it also helps us to interact with the machine. So this pointers is a very important part of it, or a very interesting part of it. What is pointer? Can anyone tell? You must have heard this or might have used this also. Can anyone tell what is a pointer in C? You can prompt in the chat box. You can answer directly by putting the mic on. What is a pointer? Have you heard of this word before? It deals with the variable location, answered by Palash. Yes, you are correct. Anyone else like to answer?
It is a variable that stores the address of other variable.
Absolutely right, Mansi. It stores the variable of other variable. What happens when I talk about the formal definition of pointer or pointer variable are special variables that are used to store addresses rather than values. Means whenever I declare, let us say that a simple int a is equal to 10, what will happen? There will be a memory allocation of 2 bytes will be done. That allocation will be named as a. That will have some location. Let us say that it is stored at location number 100, 1000, and the value of it will be 10. Okay, so value of a is 10 and value of a is 10 and address of a is 1000. Okay, that is the thing which we need to remember. So in this, a is equal to 10, but what is 1000? 1000 is the address of it. Address of variable a. 1000 is the address of variable a. So pointers are the variable, or pointers are the variables which store this address, Okay, and as it is a numerical value, it can be easily stored in a variable, in some variable. Okay, so that variable is called as a pointer variable. The pointer variables are declared in this way. There are two important symbols which we need to keep in mind in pointers. Whenever we learn in pointers, we'll asterisk symbol and a ampersand symbol. This ampersand symbol is a address of symbol, and this is called as a value at symbol. Okay, these two words you just remember, value at and address of, and never ever read this as star or ampersand. You always read these as address of and value at as far as pointer variables are concerned. If you are starting using it using these words, the concept of pointers will be very clear. Okay, so an asterisk is a symbol which is given to the or associated with a variable, and as soon as it gets associated with the variable, it will be a special variable. That variable will be a pointer variable. So like this they are declared: int asterisk p or int star p1. So what difference you can mark in these two? A space is after asterisk and a space is before asterisk. Both are valid declarations. Both are valid declarations. Anyway you can declare. So again I am repeating, pointer is a variable which stores the address of another variable. How it will do it? Let us say that there are two variables I am declaring. There are two variables I am declaring, no matter what that variables are. But as soon as I declare a variable, there will be two blocks which will be allocated to that. This variable will be known as C, and this variable will be known as PC. Okay, what this means? This means we have a one variable int star PC and another variable int C. So here C is a normal integer variable, whereas PC is a pointer variable. Okay, so C will be able to hold a normal integer value, whereas PC will be holding a an address of an integer. Okay, address of a variable. So now the next statement says C is equal to 5. So okay, forget. Just we'll come back again. There are two memory locations allocated. Let us say that the memory location allocated here is 1000, and memory location allocated here is 2000. So location number 1000 is named as C, and location number 2000 is named as PC. What is the value of C? 5. At this location 5 will be stored. So what is the value of C? Value of C is 5. What is value, address of C? Address of C is 1000. Okay. Now what is PC? PC is equal to address of C. I am reading this variable as address. PC is address of C. So what is the address of C? 1000. So what will be the value of PC? Is 1000. Okay, because PC is the address of C. PC is the address of C. What is the address of C? 1000. Now value of C 5, address of C 1000, address of PC 2000, value of PC 1000. Getting it? So this is the way we are inputting the value. Again I will see. I'll take C is equal to 5. What is address of C? Is equal to 1000. What is address of PC? 2000. What is value of PC? 1000. Are you understanding? What is value at PC? I am reading asterisk as value at. What is value at PC? Value at PC means value at location number 1000. Value at location number 1000. What is the value at location number 1000? 5. Are you understanding? This is the way we are storing. What is I can say value at location number 2000? Value at location number 2000 is 1000. Okay. So value at, read asterisk as value at, read ampersand as address of. So it will become easy. Are you understanding this? Is it clear or something to be repeated? Is it clear? If I am asking the question, please answer the chat box or directly.
Sir, repeat once again.
Repeat once again. Okay. I'll go back. Pointer is a variable, a special variable that stores the addresses of another variable. That you understand. Okay. So these are not taken into consideration for normal arithmetic, but they will be holding only values. Okay. So when I declare a variable called as, int pointer p, this means p is a variable which is going to hold the address of an integer variable. if I say float pointer f is a variable which will hold the address of a float variable. So it is called as a float pointer. This is called as a integer pointer. Likewise, I have a character pointer, I have a array pointer, I have a function pointer, I have a structure pointer. That means if I am saying that the variable is a pointer variable, it is going to hold only address, only a unsigned integer value, because address cannot be negative. Unsigned integer value it is going to hold. The data type which is mentioned in front of that, maybe here integer, here float, or in this case also integer or float. The data type which is mentioned here is just notifying us that P2 is going to hold address of a float variable. P1 is going to hold address of an integer variable. P is going to hold address of an integer variable. Okay. So this you need to keep in mind. So P, P1, P2 are special variables which will hold address. Address of some variable which is declared in your program. There are two notations which we'll have to keep in mind is asterisk and ampersand symbols. Asterisk is named as value at and ampersand is named as address of. ये दो चीजें बिल्कुल ध्यान में रखना है. Do not call whenever it is used in assignment statement. Do not call it as asterisk or ampersand. Always call it as address of or value of symbols. Okay. So if I am going for this, I'll erase all these things here. I'm declaring two variables. I'm declaring two variables. One variable is named as C, and another variable is named as PC. तो ये तो बिल्कुल simple है. So let us say that this is located at location number 1000. This is located at location number 1500. So C is a variable, PC is a variable. But if I see this declaration, C is a normal variable, PC is a special variable, that is a pointer variable. So C can hold any value of integer, it may be positive, negative, any value. And PC can hold only the address value, address of some variable. I cannot simply say PC is equal to 10. No, I cannot say this. PC is equal to 10 is not possible. Okay, it can hold only an address, and I cannot directly assign an address because I don't know where that that variable is going to get stored. So C can take any value. Likewise here, C has taken value 5. C has taken value 5. Now C has taken value 5. What we are saying, what is PC? PC is equal to address of C. What is value of C? Value of C is 5. What is address of C? Address of C is 1000. So address of C is 1000. That means this is equal to 1000. So what value PC is holding? 1000. Listen to my every word carefully. What value PC is holding? 1000. What address PC is holding? 1500. So value of PC 1000, address of PC 1500. Value of C 5, address of C is 1000. Rather, PC is the address of C. That is why. So if I am just saying that what is the value of C, I can say 5. What is address of C, I can say 1000. What is address of PC is 2000. So even though PC is a pointer variable, it is going to get stored somewhere. So that's why it is going to have some address. Now I am reading it as what is value of PC? Value of PC is address of C. What is address of C? 1000. So now if I'm saying what is value at PC, this is value of PC. What is value at PC? So value at PC means value at 1000. What value is stored at the location number 1000? 5. Okay, this is location number 1000. This is location number 1000, and value stored at location number 1000 is 5. What is value at location number 2000? Value at location 2000 is value of PC, that is 1000. So this is the way a pointer variable and a integer variable behave differently. So I hope I made the point clear.
Yes, sir.
Shall we proceed?
Yes.
Anyone else?
Yes, sir.
I'm just now see this, how I'm working on this. This is similar, the same thing. This first thing, 3 things are same. Now I have changed this c is equal to 1. Now I have changed c is equal to 1, and if I'm printing c, so what will happen if I'm, so c is now changed to 1, c is at location number 1000 and is changed to 1 now. So automatic, this is not changed at all. PC still holds the address of C. PC still holds the address of C. It is 1000 and its address is 2000. So there is no change in PC, there is change in C. So C is changed to 1. That means if I'm printing C, it is going to output 1. And if I'm now printing value at PC, it is going to print 1. Because value at PC is changed. What is PC? 1000. Value at 1000 is changed to 1. So thus I can make the changes over here, and the things will be gradually changing. Even if I am what I can do is, if I'm printing an address, this is going to print 1000. Sorry, this is going to print 1000 because PC is a address variable holding an address, and that's why I'm using a unsigned integer symbol. So value of PC is 1000, value of C is 1. So value of C can be changed automatically. The value at that location is going to change. So it is always good to access the variable with location than its value. Now let us try a small program which will make the thing clear. We have declared stdio.h, we have declared main. We need not to have any special library file for point. 2 variables are again declared, so there will be, I'll again draw. This will be PC, this will be C. See, address is not in our hands. We are just for our convenience, we are taking the addresses as 100, 200 like this. This is not in our hand. Any location which is free will be allocated to that variable. So let us say that C location number 100 is for C and location number 200 for PC. Then C is equal to 22. So now C holds value 22. Printf address of C. Printf address of C. What it is going to print? I'm reading it as address of C. Okay, they have used percent pointer, can also be a access specifier for a pointer if you are printing address. So if this line is going to print 100 because 100 is the address of C. What is the value of C? 22. It is going to print 22. Now PC is address of C. PC is address of C. Now what will be the value of PC? Address of C. Address of C is 100. So now value is changed, not yet printed. Print address of PC. What is the address of PC? Address of pointer PC is 200. This is the address of variable PC. And what is the content of pointer PC? Content. So what is the value at PC? Value at 200. Value at PC means value at 200. Value at value at 100. Value at 100 is again 20. Fine. So you can see value at PC and C are going to return the same value. Now C is changed to 11. So I'll erase this and make it 11. This is 11. Now C is equal to 11. Now what it is going to change? Address of pointer PC. What you expect? Address of pointer is going to change? No way. It is not going to change. So it will still be 200. Content of pointer PC. Now PC is 100. Value at 100 is now 11. Value at 100 is now 11. Previously it was 22. With this statement it is changed, but location is not changed. So value at PC at this point it was 22. At this point it is 11. Now if I am printing, so value at PC is 2. What is PC? PC is 100. Value at 100 is now 2. So now this value is going to get changed. See here, I can directly change the value using variable pointer. Now this value will become 2 instead of 11. Now if I print address of C, it is going to give me same answer. Address of C is 100. But value at C will be 2 now. Value of C will be 2 now. This is the way I can manipulate the pointers. But if I run this program, I will be getting this output. So you can see 22, 22, 11 and 2 are the correct answers. But as these values are not in our hands, we are not printing it. Okay. So these values are not in our hands, but if I'm talking about these values are in our hands. Okay? This is the way you are going to get the output of a program of points. Some basic mistakes which we do. Is it okay? This program is clear. Is int is the data type of C? No, I am repeating it, Palash. Many of you may be having this kind of problem. Say, if I am declaring a pointer variable P of type integer, if I am declaring a float pointer F, if I am declaring a character pointer C, even I can declare a struct. Let us say that struct student pointer S. Remember, whenever I declare these things in this way, it says that P is I'll say P holds address of an integer. P holds an address of an integer. F holds an address of a float. Character holds an address of a character variable. Likewise, S holds an address of a structure variable student. So every time we are going to have the blocks defined. So this will be P, this will be F, this will be C, this will be S. So P is going to hold address of an integer variable, like here it does. In the previous case, it does. Okay, PC is holding address of C. What is C? C is an integer variable. Okay, if PC is a float pointer, it will not be able to hold address of C. F is a float pointer. That means it holds the address of a float variable. It holds the address of a float variable. It can be, let us say, it may be something like this. Float A is equal to 10, comma, pointer variable f. If I am doing this way, if I am writing this way and I am saying f is equal to address of A. At this moment, what is happening here? F is holding address of variable A. What is variable A? A variable is a float pointer. That's why, sorry, float variable. That's why F is holding address of a float variable. In the earlier case, PC is a integer variables, hence it will be holding address of an integer variable. Lekin there are chances that this will hold 100, this will hold 150, this will hold 500, this will hold 7,000. So remember, the variable pointer variables holds a address. It will be always a numerical value. Even though it's a float value, it will be a whole number. Even if it is a character pointer, this will also be a whole number. 500. What is 500? 500 is the address of some character variable. 1000 is the address of some structure variable. So if I am saying that it's a float pointer, that means it is pointing to, or it is holding an address of a float variable. If I am saying integer pointer, it is holding address of an integer variables. Am I clear? Am I clear with the pointer? What is the type of pointer? Palash? Anyone else? Type of pointer समझ में आ रहा है? It points to some address. Okay, and pointer type gives the address of that. Pointer type gives the type of that variable for which it holds an address. Fine. Shall we proceed? Now take a pen and paper. I hope you are taking every time. Take a pen and paper and find out what's happening here. So there are variables which are declared. First is a number variable which is declared as 10. Another is a pointer variable, integer pointer variable. That means this PTR1 is going to hold address of an integer variable. Pointer PTR1 is going to hold address of an integer variable. And what is this? That we'll see later. Now, as soon as num equal to 10 is declared, what will happen? A block of memory piece of 2 bytes will be allocated. Let us say that it is allocated at location number 1000. So variable number is name num. Variable name is num. Value of num is 10. Address of num is 1000. So here it is written value of num and address of num. What will happen with the next line? New variable PTR1 will be declared. It will its address of PTR1 is 2000, and but it is a pointer variable and now holding address of num. It is holding address of num. Okay, what is address of num? 1000. So what is value of PTR1? 1000. And what is address of PTR1? 2000. So this way it is happening. Now, so PTR1 is an integer pointer, hence it is pointing to an integer called as num. What about this? It is a pointer to a pointer to an integer. Okay, this is an integer. This is pointer to an integer. This is pointer to a pointer to an integer. Pointer to a pointer of to an integer. So what will happen here now? See, num is declared. It is at address 1000. This 1000 it is stored in PTR1. Its address is 2000. Okay, and its address is stored in a variable PTR2 whose address is 3000. So what I can say, this is an integer, this is a pointer to an integer, and this is a pointer to a pointer to an integer. So what this holds? This holds address of PTR1. Are you understanding me? So this is happening in C. Let us just repeat in a different way. What is value of num? What is address of num? Address of num is 1000. What is value of PTR1? PTR1 की वैल्यू क्या है? एड्रेस ऑफ num. एड्रेस ऑफ num क्या है? 1000. What is address of PTR1? 2000. Okay. What is PTR2? PTR2 is address of PTR1. What is address of PTR1? 2000. Getting me? What is address of PTR2? 3000. Let us say what is value at PTR1? Value at PTR1 means value at 1000. Value at 1000 is 10. Value at PTR1 is 10. What is value at PTR2? Value at PTR2 means value at 2000. So it is 1000. Okay, this way the pointer works. Or I can again have an extra pointer over here which can hold address of this pointer also. Let us say that PTR3. Let us say that it is at location number 4000 and it is address of this one, so it will hold 3000. It is pointing here. Okay, so this is address of PTR3. This is value of PTR3, which is address of PTR2. This is value of PTR2, which is address of PTR1. This is value of PTR1, which is address of num. So this is an integer. This is an integer variable. This is an integer variable. This is a pointer to an integer. This is pointer to a pointer to an integer. This is pointer to a pointer of an integer. How I am going to declare this? I am going to declare this as star. Yes, for you I am saying it as star, which is a asterisk symbol. Star 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 p. PTR3. इसका डिक्लेरेशन ऐसा है. Star 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 PTR3 means pointer to a pointer to a pointer to an integer. Okay, So this way you can have a pointer to 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 a pointer till infinite. Everything is permitted in C because every pointer variable is a variable which will be stored in the memory. Okay, of course it is a special type of variable. The value it can store will be only unsigned integer. All these things are there, but it will always be inexistent, physically existent in the memory piece. That's why it is taken care of. Is it fine? Any doubt? You can put it in the chat box or you can ask. Is it clear? Yeah. Can pointer 3 store address of pointer 1? Uh, it can, but we'll have to now declare it as a pointer to a pointer. Okay, we cannot have 3 stars here. We'll have only two stars. Anything else? Anyone else have a doubt? या बिल्कुल कुछ भी समझ में नहीं आया? चलो ठीक है, we'll proceed further. As pointer to stored it earlier, is it possible once again? It is possible. You can store that. You can have n number of variables storing the same address. You can have n number of variables storing the same address. There is no issue because I can store 10 in value 10 in 10 different variables. Similarly, I can store one address in 10 different variables. Okay, if this has only PTR star PTR2, it can definitely store. Fine. The last part of today's lecture. Take a pen and paper and find this. There is a value, there is a variable I, so it will be of integer type. P is a pointer to an integer. Q is a pointer to a pointer to an integer. R is a pointer to a pointer to a pointer to an integer. Okay. So let us say that I is equal to 10. P holds address of I. So let us just will declare 4 things, 4 variables. There are 4 variables. I holding value 10 and P holding address of I, Q holding address of P, and R holding address of Q. Sorry, I have just made a mistake. Okay, this should be address of P. Not I. This should be address of P, and this should be address of Q. This should be address of Q. So let us say that address of I is 500, our assumptions. Address of P is 800. And address of Q is 1000. And let us say that address of R is 1200. 1200. So now what I want is, I want these values. I'll ask a question to especially this. I is no need to tell, I is 10. I is 10. Ashish Omre, can you tell what will be value of P and Q?
Sir, in P, the address of I.
Tell me the actual number which I'll put here.
500, sir.
500. And what about Q?
Q is the address of P 800.
Q will be 800. Okay. Next is, can I get from Dipanshu? Dipanshu,
Yes, sir. Yes, sir.
What is R?
Sir, R is it is 800.
R is 800. Sure. How?
Sir, I'm not sure.
Okay. Harsh, Nipane?
Yes, sir, it's 1000.
It's 1000. Yes, 1000 is correct. See how you are getting these values. I is initialized to 10. P holds the address of I, which is assumed as 500. Q holds the address of P, which is assumed as address of P assumed as 800. And R holds the address of Q is assumed as 1000. Now, can Janvi tell me what is value at P?
10.
Okay, value at P is 10. Jessel, value at Q? Jessel. Jessel is not there. I'm removing you. Jessel, what is the answer? My problem. Tell me the answer in the chat box. Value at Q. Value at Q is 500. Absolutely right. How value of Q is 500? As everyone understood. Value at what is the value of Q? Value of Q is 800. What is value at 800 is 500. Why 500? Because we have already written the values over here. 500, 800 in this case, and 1000 here. So what will be the pointer to R? Sorry, value at R. Can I get the answer from Karan?
Yes, sir. 800.
800. Karan, you can also tell this value. Value at Q. It's very simple. See, you understand it this way. What is value at Q?
That Q is 500.
Value Q is 500. What is value? Q is 500. No.
No, sir. Uh,
What is
Q
Q?
is 800.
Q is 800. What is value at Q? So it will be written in this way. Okay. So what is value at 800?
500.
Is 500. So what is value at 500? Value at 500 is 10.
10 then.
Okay.
Yes, sir. Yes.
So this way you can find out rest of the things. What is value at R? So R is 1000. Value at R, value at 1000 is 800. Value at 800 is 500, and value at 500 is 10. Value at R, so R is 1000, value at R is 800, and value at 800 is 500. I'm just finishing it fast because I have another lecture also. And what is value at Q? Q is 800, value at Q is, it is already taken, I guess, 500. So this way, the rest of the things are done. So I request you, I'll post this in the Moodle. Go through this once again, practice it, and if you have any problems, we'll solve those doubts tomorrow. Right now, I'll stop here. So I hope that I made a few of these points clear. Not sure about all, but if you have any doubts, definitely post your doubts tomorrow or come up with the doubts tomorrow, because unless until you have clear-cut idea about pointers, there is no further movement in data structure. So be very clear that we need to be very clear about this pointers. So please go through this PPT. I'll upload this PPT in our Moodle platform. Please go through that. Okay. Thank you. Thank you very much. You may leave now.